Hi friends, मैं हूँ आपका दोस्त अमित and in the last video I have explained you the concept of moment of inertia. Now in this video I will solve one numerical uh, which is for the I section, right, and we will find out the moment of inertia for both the axes, that is x dash as well as y dash. So let's start the video. So first for x dash, so basically I am using here a different method for finding out the moment of inertia. You can use, there is another method which is based on the parallel axis theorem. You can use that and you can find out using that also. But this is that process is very lengthy. So I am using here one shortcut. So what I'll do, I'll consider this whole cross section as a rectangle and I'll find out the moment of inertia for that. And what I'll do, I'll subtract the moment of inertia of these two rectangles over here. Okay, as you can see in the figure, these are two rectangles which we need to subtract from the rectangle to find out the moment of inertia for this I section, right? So that will be 2 into b d cube by 12. So now here the breadth is 250 into the depth is 300 raised to 3 and 12. Also one more thing, the thicknesses, that is the flange and web thicknesses are same, that is 10.6. The breadth is 250 mm, depth is 300 mm. Okay, so 250 300 raised to 3 minus divided by 12 minus b. Now here we want to find out the breadth of this rectangle over here. Okay, so I'll use the calculator. 250 divided by 2, that is 125. So this distance, okay, half of 250, that is 125, right? So I need to minus from this 125, I need to minus or I need to subtract this much thickness to find out the width of this cross section. Okay, so 125 answer minus 10.6 is my thickness divided by 2. Okay, so 199.7 199.7 as you can see over here. So this is my breadth of this section, 119.7. Okay, multiplied by the depth. Now here I want to find out depth. So 300 is my total depth minus, I need to minus the two thicknesses of flanges, 2 into 10.6 to 78.8. Whole divided by raised to 3 divided by 6 over there. Okay, this is 6 over here. Okay, now if you solve this equation over here, you will get the answer, that is 130 multiplied by 10 raised to minus 6 meter raised to 4 ix x dash, right? Okay. Now what we will do, we will find out for the y dash also. Okay, so now for finding out the moment of inertia for y dash is this vertical axis, no? So what I'll do, as you can see in this figure, there are three rectangles. This is first, this is second, and this is third rectangle. So what I'll do, I'll find out the moment of inertia or individual moment of inertia of these portions and I'll add them to find out my overall moment of inertia y dash. Right? So I1 for the first rectangle, I2 and I3. Okay, so these are the moment of inertia of the individual rectangles over here. Okay, as you can see in this figure, this is one, second, and this is third rectangle over here. Okay, so I'll find the moment of inertia about the vertical axis only. So for I1, this rectangle over here. Okay, so the formula, as you know the formula, db cube by 12, right? db cube by 12 for first section, then db cube by 12 for this second rectangle, what I can see, and db cube by 12 for this third. As you can see, the dimensions, depth and breadth for this first and third rectangle are same. So basically the moment of inertia will be also same. So I'll write here over 1. So this will be 2 into db cube by 12 for the first rectangle and db cube by 12 for second. Okay, now for the first, so depth is what? It is 10.6, no? 10.6 multiplied by the breadth is 250 raised to 3 divided by 6 plus for this rectangle over here, present value. For this, the depth is I guess the depth is we have calculated it, no? This is 278.8. 278.8 multiplied by the breadth. The breadth is 10.6 raised to 3 whole divided by 12, right? So this is the equation. Now we have to solve this equation, and after solving this equation you will get the IYY as 27.63 into 10 raised to minus 6 meter raised to 4. This is my IYY dash, right? Okay, so this is my IYY dash and this is my IXX dash. Okay, thank you for the watching this video. If you have any doubts regarding this video, you can type in the comment. Right. And if you have not watched my fixed line moment and moment of inertia video, then you can watch that video, and I'll give the link in the description. Thank you.